In this nugget, you and I get to lab up and verify IPv6 and RIP next generation. Let's begin. IPv6 has a lot going on. In this lab, we're going to build a topology with two simple routers. We'll use the network address space of 2001:db8:. The X represents the subnet. Over here we have subnet 1 for loopback 0, subnet 2 for loopback 0 on R2, and subnet 12 for the IPv6 network, connecting them directly together. Our laundry list of items we're going to do include enabling IPv6 unicast routing. We'll configure the global addresses. We'll go ahead and let the systems automatically configure their link local addresses using EUI64. We'll enable IPv6's RIPng, and then verify that we have full reachability between loopback 0 on R1 and loopback 0 on R2. So let's get this party started. Let's bring out a couple of routers. I'm going to bring out a 7200 series for R1 and a 7200 series for R2. And if you need a refresher on the basics of GNS3, please check out our GNS3 1.x fundamentals course. Next, we're going to link them together by using the connector tool or the link tool right here. And we'll go from R1's Ethernet 3/0 over to R2's Ethernet 3/0. I'll turn off that link tool, and we'll turn on the label tool right here just to verify we have the correct interfaces. Then we'll start the topology by using the start icon from the toolbar. And then we'll open up consoles to each of these devices using the console icon. Now, in the demonstration, I'm currently using iOS 15, but you could use iOS 12.x as well. That'd be perfectly fine, as long as it has the feature set that includes IPv6. So, beginning here on R1, let's go into configuration mode and enable IPv6 unicast routing with the syntax IPv6 space unicast-routing. And now, as a result of that command, this router is willing to route IPv6 packets on behalf of other devices. Next, let's go into interface Ethernet 3/0, and we're going to manually assign a MAC address. You might say, well, Keith, why are we manually assigning a MAC address? And I'm glad you asked. The reason we're doing it on this interface is that so that when the EUI64 address is created, it'll be very easy for us to see how it took the MAC address that was on that interface and it used that in its creation of the EUI64 address. Next, let's assign a globally addressable IPv6 address using the command IPv6 address 2001:db8:12:1/64. And that is the IPv6 address we're assigning to Ethernet 3/0. Now, for that global address, we hard-coded what the host ID is, the interface ID, the last 64 bits, which is all zeros and a 1 in that last position. We also want to enable IPv6's RIP, so let's do that with the syntax IPv6 RIP, the name of our RIP process, and then the keyword enable. Now, this interface, Ethernet 3/0, is not doing a whole bunch yet because it is still shut down. So, of course, we want to bring it up with a no shutdown command, and then we'll exit out of interface configuration mode. Next, let's focus our attention on the loopback 0 interface, which on R1 doesn't exist yet, so we'll create it by going into interface loopback 0. Now it exists. We'll give the IPv6 address of 2001:db8:1:1 with a 64-bit mask, and we'll enable RIP on that interface as well. And you might ask, well, Keith, how come we're enabling RIP on a loopback interface? And that's because we want that interface and the network, more importantly, connected to the interface to be advertised via RIP from R1 over to R2. And that way R2 can learn about the one subnet learned via RIP. Next, let's make a road trip over to our good buddy R2. And at R2, we'll go into configuration mode and we'll enable IPv6 unicast-routing there as well. Next, we'll go into interface 3/0, that's Ethernet 3/0, and we'll give it the MAC address with 0000, ending with 8 2s. And again, the reason for doing that, it makes it a lot easier when we look at the EUI64 formatted address to identify exactly how it created that based on the MAC address. We're also going to assign a global address. We're going to assign the entire 128 bits of 2001 DB8 12 2/64. So that 12 subnet is the network between R1 and R2. And in our topology, the router number, for example, R1 or R2, that's going to match the last number in the IPv6 address as well, at least for the addresses that we assign. We want to enable this Ethernet 3/0 interface for RIPng, so we'll use the syntax IPv6 RIP, the name of our RIP process, and then the keyword enable. We also want to bring up this interface, so we'll do a no shutdown, and then we'll exit out of interface configuration mode. Our last piece of the puzzle is the loopback 0 here on R2. So we'll go ahead and create interface loopback 0. We'll assign it the IPv6 address of 2001 DB8 2 with a 64-bit mask, and we'll include it as well in the routing process for RIP next generation that's running on R2. Now for the all-important verification, let's do a show IPv6 route to see all of the IPv6 routes on R2. In the output of show IPv6 route, we have this RIP learned route right here. This says, hey, I know about the 2001 DB8 network. That's the network that loopback 0 is connected to. Here's the administrative distance of 120 for RIP next generation. And here's our metric, which is 2. And one interesting note is that you might think, well, R2 is really only one hop away from that network. How come it's showing 2? And for IPv6's RIP next generation, R1 would be advertising this with a hop count of 1. And when R2 receives it, it would be adding a hop count of 1 before it puts it in the routing table. That's just the way IPv6 works on a Cisco iOS router. If we were running RIP for IP version 4, R2 would see this subnet, if it was an IPv4 subnet, as a hop count of 1. Also notice here that the next hop is the link local address of R1. And we can tell that based on all these ones that are in the EUI64 created address for R1's link local address associated with Ethernet 3/0. And we should be able to ping. So if we did a ping to 2001 DB8 1 : 1 and we sourced it from our loopback 0, that would verify that R2 can reach R1's loopback 0 of subnet 1, and that R1 also can reply back to us to our subnet 2, which is based on R2's loopback 0. And because we got 5 out of 5, that's verified that it's working. Now, regarding all the addresses that are involved on R2 and R1, here on R2, if we use the command show IPv6 interface for Ethernet 3/0, we have a bunch of fantastic information here, including the link local address, which begins with FE80, and then the last 64 bits was created due to EUI64. So on a Cisco router, it took the MAC address, it flipped the 7th bit from the left, and then it wedged in FFFE in the middle of that. And that created the 64-bit host address that it's using as part of its link local address. We also have here the global address that we hard-coded of 2001 DB8 12 : 2, which is on the 12 subnet. This interface has also joined some multicast groups that begin with FF. We have : 1, which represents the all IPv6 nodes on the network. : 2 represents IPv6 routers on the network. : 9 represents IPv6 next generation RIP speaking routers. And this guy right here and this guy right here, these are both solicited node multicast group addresses based on the addresses that are currently in use by this interface. So the fact that we have a host address that ends in : 2, and we also have this link local address, which has a whole bunch of different numbers for the last 64 bits. This router interface has joined the two respective multicast groups associated with those host IDs. And for greater detail on how that calculation happens and how this solicited node multicast group works, I would invite you to join me in our IPv6 course right here at CBT Nuggets. And that has a lot of additional detail on solicited node multicast groups and a whole bunch more surrounding the concept of IPv6. We could also do a show IPv6 protocols just to verify what IPv6 routing protocols are running on this router. And here with the output of show IPv6 protocols, it's showing us that we have a RIP process that's named our RIP and that loopback 0 and interface 3/0 are currently participating as part of that routing process. We can also issue the command debug IPv6 RIP. Again, we are in a lab environment. It's not a huge deal right here. And with the debug in place, we'll be able to see the updates that are being periodically sent. So I've turned off debug for IPv6 RIP. And if we look at one of the outbound messages that we're sending, we can see that the packets, the routing updates, are sourced from the link local addresses on the routers. Because it's RIP, the destination was the multicast group of FF02::9. The source port and destination port being used are port 521. And here it's also showing the advertised metric that's being advertised with these two networks. There's the 12 network and the 2 network that R2 is sending out in this RIP update that we're looking at right here. So it's treating both directly connected networks and advertising them with a metric of 1. You'll also notice here that R2 is not advertising the 1 subnet, and that's because R2 learned about the 1 subnet on this 3/0 interface, and that's why we don't see that network being advertised back out due to split horizon on this same interface. All of the configuration that we just did in this nugget together are available as part of the Nugget Lab files, along with the topology diagram for the network that we just built. And as part of this lab, we enabled IPv6, we configured interfaces, we configured RIP next generation, and then we verified connectivity from one side of the network to the other. We also identified the IPv6 addresses that were currently in use, as well as the multicast groups joined by an interface. And for additional training regarding IPv6, I would refer you to CCNP Route. There's an entire IPv6 course right here at CBT Nuggets. And if you're interested in more step-by-step hands-on labs, we also have a CCNA hands-on lab, which also has IPv6 included as part of that. I have had a lot of fun in this nugget. I'm so glad you joined me for it. I hope this has been informative for you, and I'd like to thank you for viewing.